Welcome. Advanced SSH, of course, SSH is an infinite topic, and the thoughts about what is advanced and what isn't widely vary. So we'll give you a few prerequisites, what we won't cover anymore, so that we get to our definition of what we consider mostly advanced or maybe even a little uncommon. But all these things are taken from everyday practice, since we're both sysadmins and OpenSSH is our daily tool set.
So we basically won't talk about SSH config. We assume you all know how to configure your host connections and do the proper configuration in there.
Of course, you're already using public key authentication with ED25519 keys or RSA public keys.
Of course, we won't talk about port forwardings, local forwarding, remote forwarding, dynamic forwarding, X11 forwarding, all things you already do, you already use in everyday work, so we won't cover that as well.
And of course, you know how to copy files with SCP and SFTP. And of course, yeah, rsync, the occasional thing. And of course, what we won't cover as well is we all know tar rainbows are magic, and we'll not go into that black magic anymore. So, SSH, it's infinite. Of course, everything in this talk is 90-11% certified to work on my machine. So your mileage will vary, and yeah.
Hopefully it will work on my machine as well, otherwise we will get into trouble later on.
We'll see that we sacrificed
enough
beings to yeah, hope the demo gods will be gentle to us. So, security config. Some things you usually take for granted is your crypto config of your SSH client and server. Usually nobody ever looks into that. And of course, there's things you can improve upon. So let's dig into it. There's the key exchange algorithms, which SSH uses. If you're lucky and you're using OpenSSH 6.3 or above, there you can easily ask your client or server which key exchange algorithms are supported with a -q option and kex as a keyword. Of course, you can always consult the friendly man pages. This will give you on a recently released 7.3 P1 OpenSSH, you get this list of supported key exchange algorithms. And we'll try to thin that out a little to see what we can use in the future. Of course, there's the IKDH Oakley groups. Group 14 or less is 2048 bits. That's considered not enough these days anymore, so we'll get rid of that. Everything else, if you run group 16, you get 4096 bits, and group 18 is 8192 bits. And both sides need to support the algorithms you use. Of course, we don't like SHA-1 anymore. It's not really a security problem in SSH use, but SHA-1 is not getting any better these days. And since it's already a little smelly, we'll choose to get rid of it. Yeah. Then, if you don't trust the NIST ECC curves, of course you can disable those. If you still think NIST has some nice recommendations, they recommend to use SHA-512 or SHA-384 these days. You can get rid of SHA-256 handshakes as well. And if you like to use the Diffie-Hellman group exchange with SHA-256, you also have to edit your etc moduli file, which looks like this. It's not any more readable in the front than in the back, so it's a long file of gibberish. Of course, that's all prime numbers we use, and if you look into a recent OpenBSD 6.0 release, you get a moduli file that looks similar to this, and I recommend getting rid of anything that is less than 4000 bits. So the fifth column you see here with the 1023, the size column gives you an indicator, and you just comment out anything that you don't like. Especially OS X is prone to ship rather, I'd say ancient is the word, release of that. So once you've done that...
Well tested.
Yeah, tried and proven.
Yeah.
Yeah. So this leaves us with this list of key exchange algorithm in the preferred order. which is easily enough to be configured. You can just pretty much copy paste that line into your client and server config and use those. Of course, curve 25519 is the famous DJ Bernstein curve that's widely used now, and it's especially nice because it's free, libre, and gratis. All the three freedoms you like to have. There's constant time reference implementation, so there's no known side channel attacks against this curve, and it's also friendly and fast on lower powered ARM-based machines like your light bulbs, your toaster, or your phone, if it doesn't have a hardware acceleration for some things. So if you like to have a switch, doesn't switch, it does switch. Yeah, so to easily configure client and server.
Now it's switched.
It switched, oh, okay. Yeah. You can use, of course, the host star option, which is a general configuration option for all the SSH hosts in your config file, which is quite comfortably, and if you need to override something, we'll get to that. Of course, there's the key types, the public key accepted key types, which means the public key algorithms that the server can use to authenticate itself to the client. So what your client will accept as key types, you can again ask your SSH version. Again, gives you a rather nice list of stuff, and we'll also get rid of a few things here. Of course, we don't want to use DSS, which is the OpenSSH DSA implementation, and ECDSA is also not very likely to be fine anymore. OpenSSH 7.0 started to really get rid of a lot of these things, so they're progressing forward and getting rid of old and bad crypto. So we'll just strike those out. And
you have to click for earlier.
I have to click earlier. Yeah. This thing is doing something in the background it should not be doing. It really is.
You can fix that once we are.
Yeah.
Something is
really wrong with this machine.
So the next slide would show the list of all the ciphers striken out. It will eventually get to render these on the screen, but you can.
Yeah, okay. Something is swapping here. I'm sorry for that. Yeah, so once we got rid of those, it leaves us with another short list of algorithms and options we can use.
And of course, you can put that in the host file, in the config file as well.
In the config file as well. Okay, that's also quite easy. Okay.
I think your machine?
My machine, yeah.
Your machine, okay.
This short break is sponsored by Apple by providing a fancy kernel. No, it's not a kernel panic. Oh, how lucky I am. I thought it
GPU
was.
overheating?
GPU overheating, no, it's something is swapping here. I know what's swapping. Hang on a second, I got this.
Famous last words.
Famous last word. Talk about message authentication algorithms.
Why me? That's your part of the talk. I have to talk later on.
Yeah.
So,
I need a working terminal to get rid of this process. I know what it is. Okay. Yeah, of course. Message authentication algorithms are used to provide the integrity of your. It's really hard to talk while waiting for a terminal to show up. To provide the integrity of your conversation between the client and the server. And of course, there's some algorithms you can use and some you should not.
And we will get to that list shortly once Pepe killed that one pesky process that's just messing everything up at the moment. What the list are? Yeah. So once we finished, please kill the process in the right window.
Can you turn down this? Because we don't need that.
This is the first time it worked. The sound from the laptop.
I don't need sound.
Yeah. So.
We were here.
Hey.
Should be better now. Okay. Yeah. Message authentication. Yeah. Server provides the identity to the client by signing the key resulting from the key exchange, and there's multiple algorithms used. And again, you already know how to ask your client if you're on 6.3 and above, and if you're not, there's this fancy thing you could use. It gives you the same results, it's just not as easily to remember. There's a lot of message MACs there. Of course, there's 3 common ways to do this. There's encrypt then MAC, which means you encrypt the message and then attach the message authentication to the cipher code. Then there's MAC then encrypt, which means you first attach the message authentication code to the plain text and then encrypt everything. And there's encrypt and MAC, which means encrypting the message and then attaching the message authentication code of the plain text to the ciphertext. Of course, most of those do not make any sense at all, and we know there's fancy padding oracles coming from this, so encrypt then MAC, ETM, which you can find in some of these modes, is the only one that you should be using. So we strike everything out that's not using that one. Of course, MD5, we know all that this is broken, and we don't like it, even if HMACs don't need collision resistance. SHA-1, we already talked about that. Let's get rid of that as well. And everything below 128 bits of tag size is also not really up to date anymore. So that's a very friendly short list you can use. And since there are no known downgrade attacks for Macs, that's easy to just list them in this order up to the not so lovely ones, but still working fine. Once all this handshaking and authentication has happened, of course, you end up with a symmetric cipher that is actually used to encrypt your connection. And you already have guessed this probably, how to ask your client what they support. Still a huge list, and we'll get rid of anything that is a 64-bit block cipher, which means getting rid of DES and Blowfish and CAST and all that stuff.
Even Bruce Snyder, who developed Blowfish, said don't use it anymore.
Yeah,
so
yeah.
just
Get rid of that. Of course, CBC mode, cipher blockchaining mode, that has some trouble too. Let's get rid of those. And yeah, RC4, we'll not talk about RC4 anymore. So, nicely short list again. This is what you end up with. The ChaCha20 Poly 1305 and AES in GCM mode, in Galois counter mode. These are so-called AEAD ciphers, which means this authenticated data, encryption with authenticated data, which means they don't need a special message authentication code that is implicit with the encryption. And of course, AES in GCM is usually really fast when using hardware that supports AES-NI, which means hardware encryption support on your Intel CPU, and if you're on ARM, there's the Neon extensions that hardware accelerate that as well. So there's no excuses for using good crypto in that regard. And ChaCha20 Poly 1305 is also really fast on ARM devices. So that's usually for the low power devices. That's really handy to use. Yeah. And if you only want to use these modes, you can explicitly ask for only those, and you'll get the list that is expected with just these 3. So that's your easy way to configure proper crypto on your server and client. You'll get the slides so you can copy paste that and also find out what your client supports. Is everyone still with us?
fallen asleep.
If you're sleeping, snore silently so you don't wake up your neighbors. And so far we've talked about clients and servers talking to each other and authenticating each other. What about users?
We don't like users.
Yeah, since Tron users have
they just break stuff.
They break stuff, yeah.
So one of the things we want to talk about in advanced SSH is two-factor authentication for authenticating against a remote system. So usually, as we all know, we have set up public key authentication, but there are times when you still need the password and you want to have a second factor to make that password more secure, or to give users an additional security barrier before they lose their account. So with two-factor authentication, there are ways around two-factor authentication. We all seen them on the interwebs.
You all know the RSA tokens. Anyone want to buy one of these? Or 200? They're rather clumsy and people lose them.
I think Amazon has now a bundle. Buy one RSA token and get a free webcam.
Oh, yeah. This is usually then a nice setup you can recommend. You put the token up there, webcam in front of it. You can even use computer vision to read the codes. That's quite comfortable. Also, people don't lose the RSA tokens anymore. And if you need multiple of them,
there are solutions for that as well.
Yeah.
So what we actually want to use is not our RSA tokens, but our time-based one-time pads that basically are documented in an RFC, and there are actually quite a few applications to use for those. So one of the best known ones is the Google Authenticator, but there are lots of third-party apps if you don't want to use, can't or don't want to use Google Authenticator. There's even an app for a Windows 10 phone, so surprisingly.
Yeah, there's an app for phones that don't exist.
Yeah.
So, yeah, just as an example.
Blackberries?
Even Blackberries.
Even Blackberries. Even Blackberries.
Awesome.
Wow.
Another software-only platform.
Yeah.
Yeah.
Okay.
As an example here, there's Google Authenticator and 1Password as a commercial option and a free option, and there's tons of others. And so to install these things,
on a Debian flavored Linux, it's apt-get install Google Authenticator, so it's really half a day's work at least.
Yeah.
For BSD, that's your kink.
Yeah, that's just you install those 2 ports and you're done. And of course, you need to tell your PAM, your pluggable authentication modules, that, hey, there's a new module, you want to talk to that. And that's also half a day of work to add this line. There are
a few options for that to make that, as it says here, it's optional. The PAM Google Authenticator is optional. You can make it mandatory. You can switch around a few parameters once you have established that your users actually can work with the Google Authenticator. But take a look at the manual page. It's quite thorough on that topic. But for our demo, what we are trying to show you, this is the line you have to add to PAMD SSHD.
Exactly. And of course, your SSHD config needs to know about this as well. So your authentication methods. Of course, we're using public key, and we're adding a keyboard interactive second factor, which is the time-based one-time pad to that. Of course, we disallow password authentication, but we must enable challenge response authentication, since the challenge is I'm asking for a one-time token and you need to respond to that. Of course, you can mix and match those however you like.
So that is basically what you have to do on the server side. So for management, it's basically at least 1 day of work and another day for documentation. And then all the users have to do something as well.
Yeah, of course, that's billable hours.
Yeah.
Yeah. You need to set up Google Authenticator on the server, so you just log in as usual like you're used to, run Google Authenticator, and this will bring us to the live demo.
Ooh. First live demo. So
first live demo.
If you switch over, excellent. So let's if I press the right keys, it actually works. Yeah. So as we said before, we are connecting to the remote system. And as we said before, it asks for the password
of your local key.
Of my local key, and I'm connected to the remote system, where I can now run the Google Authenticator. Do I want my authentication tokens to be one-time passed? Yes, that's basically why we are using this. And what it does now is it generates me a new secret key. This secret key I can enter manually into the phone to synchronize the Google Authenticator on the server with the Google Authenticator on the smartphone. And if I lose my smartphone, I could use the 5 emergency scratch codes to authenticate even without the phone. So you want to probably print or write those down and put them somewhere safe. It also asks me if I want to update my .google authenticator file. Of course, I say yes as well, because otherwise it won't write down the configuration and I can't use Google Authenticator. Do I want to disallow multiple uses of the same authentication token? That's basically a security feature. So I can use the token only once every 30 seconds. So if I mistype it or if I make a mistake, I have to wait half a minute before I can try again with a new code. So I will say yes to this as well. Tokens are default good for 30 seconds. If I'm a slow typer like a manager, or if I have problems with my time synchronization, I can extend that time, how long the token will be usable. But for our demo purposes, the 30 seconds we have here are good. And I have to say yes.
Yes, you do.
And I can also limit the number of attempts to 3 per every 30 seconds in order to prevent brute force login attempts. So this is usually a good thing as well. And what happened now is that the Google Authenticator created a .google Authenticator file, which basically looks like this. And so the 5 emergency codes are there, as well as the synchronization token. So the other thing the Google Authenticator created, which you weren't able to see because of the resolution, was a QR code the system generated. Yeah. And you're peeping.
I'm peeping, yeah. We don't need peeping.
Wherever that comes from. So what we can do is we use the QR code to connect the smartphone app to the Google Authenticator instance we use on this server. So for every server you're using, you get a different code and you get a different number generated.
Exactly. So, to show you that, I would ask you to detach from that TMUX session so we get the other resolution. Because you have probably seen there has been some things scrolling by and it looked really...
Please proceed.
Yeah, you did not detach that session. So we need it. What's the prefix? It's not this one?
B.
Ah, okay, this one. Yeah, once you get the red keys, it works. So we'll just use the friendly scroll back here, which is...
Control B.
This one? No, it's Control B. That one? It's this one? Yeah, now it works. So we're scrolling back here, and this is what you have been seeing flying by. It's actually a QR code. So you can see the phone here on the right-hand side of the screen, and in the left upper-hand corner we have a Google Authenticator. And when we launch that, we'll say, hi, do you want to set it up? Yes, I'll begin the setup by scanning a barcode. And need to get closer. Yeah,
it worked.
Wonderful. So that's pretty much all I need to do. And now you can see every 30 seconds it generates a new code. It has taken the username and the host name automatically. And in the right-hand corner of the code, you also see this kind of tiny spinner that tells you how long that code is still valid. And once it starts blinking reddish at you, you either have to type fast or hope you get a grace period of a few seconds to enter that code. And then it switches to the next one, like now.
Right, so I'll attach to the session again. So this will break everything. Excellent.
No, we're fine.
We're fine, okay. Could you scroll down again? Yeah. Because that's something you have to do.
Und jetzt musst du Return drücken. Nein?
Come on.
Enter.
No. Yeah.
Yeah, that's always the funny things between your term cap on 3 different machines.
And we're still in scroll mode.
Yeah, which should just use. No.
We're giving a talk on TMUX usage as well, so trust us, we know what we are doing.
The great thing is, this happens every time, and every time it's different. So,
because he can enable the TMUX scroll mode, because I can't because of my keyboard mapping, but getting out of that scroll mode again is always rather interesting.
We'll just use another terminal.
Okay, so what I can do now is connect to the server again. And if I've done everything right, it should now ask for the password. So that would be this one. And now it asks for the verification code. And that's the code the application is generating. I can see it up there. So I'll wait for the next one, because that's one. Okay, 924. And I'm logged in. So this is rather nice. So we have now combined password authentication with with the time-based authentication. You can, of course, combine that with everything you want. So you can combine it with certificate-based authentication as well.
Yeah.
Could be handy.
Absolutely.
In some cases.
And as you also can see on the window where the phone is seen, that is in flight mode, so you don't need any network connection. I can turn the Wi-Fi off on that as well. That's not needed. So if you're in the data center in the 7th basement, that will still work. And usually people don't forget their phones, which is a nice thing. And
because they have to tweet the NSA stickers from the racks.
Yeah, of course.
Once they are online again. Okay.
That concludes the demo of Google Authenticator for two-factor authentication, and also the larger chapter of the security configuration. Of course, sometimes you cannot directly connect from one host to another, and you need to jump through another host, or a bastion host as they're sometimes called. We'll continue with the live demo for that. Jumping between a few SSH hosts, and I think we have to.
Let's speed this up. Okay. So again, I can connect. Let's just show you how this works manually. I connect to my bastion host. Let me just add the. That's because Pepe created a new agent. Let me just start the SSH agent. So. Jo. Wo haben wir es? Da haben wir es. Wieso funktioniert das jetzt nicht? Give me a sec. This will work.
It's always the demo goats.
Yeah.
We need another goat.
So. And do this as well. Yeah.
Okay.
So
here we go.
There we go. Now I can add my SSH host to the SSH agent, and then I won't need those pesky. Better. So, what I was talking about is connecting to the jump host. I know why. So I'm now on my jump host or bastion host, which basically is the intermediate step before I can connect to the internal system. For example, my SAP system or my internal whatever server I'm running there. So from the bastion host, I do another SSH to the internal system.
Of course, we've checked the fingerprint we all know by heart.
And now I'm on my destination system, which I want to connect it to in the first place. So this is rather cumbersome, and if you have to do this several times a day, it gets really annoying and boring. So there are quite a few ways to achieve that type of host jumping with SSH in a more automatic and useful way. With OpenSSH 7.3, the wonderful girls and guys at OpenSSH added a new option called -J. With -J, you can actually just say, use this host as a jump host to connect to the remote machine. And the nice thing is I can not only use one jump host, but actually several jump hosts. So if I need to connect through several hosts to get to my destination machine, I can just specify them on one command line, and I'll be good to go. So let's try this again, but not manually, but automatically. So SSH -J, then the jump host, which is host 01, and then the final destination, which is SSH host 02. And of course, as my SSH agent doesn't work as I'm expecting it to be. It asked me for the password, but it only asked me for the password of the second machine. So I was automatically authenticated on my jump host and automatically reconnected to my destination host. I can even, as I'm a rather lazy guy, I can actually do a lot better with an entry in my SSH config file. As you can see in the last line, there's the proxy jump host. The proxy jump host is defined as host 01, which is defined further up. So I have the identity file and the proxy jump host. So all I have to do now is say SSH PJ. I'm automatically connected to my second destination server. And now, as I'm using the right identity files, I didn't even need to authenticate, as this was all done through the SSH agent. The nice thing about that is the connection to the second server is tunneled through the first server. So the first server doesn't see anything in regards to authentication data for the second server. I don't need password files. I don't need private key files on the Bastion host to connect securely and properly to the destination server.
You also don't need a shell on the Bastion host, of course, which is what we recommend when using a Bastion host. And it will also not transfer any private key material to the Bastion host like agent forwarding does, which you can totally circumvent by using this method. So you really want to upgrade to SSH 7.3.
If for some obscure reason you can't upgrade, there's always the proxy command that already worked in earlier versions. So -o proxy command SSH and then give it the jump host as well will connect me to my servers as I haven't set up my SSH agent improperly again. I had to enter my password here. Again, this is done in a rather secure and proper way. If you have an even older SSH version that doesn't support the proxy command, you can use TTY allocation, so you can use the same feature again with -TT, and this basically does the same thing again and connects me to my destination host. If you have a version that's even older, like SSH version prior to version 5.4, yes, we're talking about agent software now, you can still use netcat to tunnel through and get to your destination host again. No, we'll skip that. We'll skip that now because
you can have it.
No.
Yeah.
No.
So you see, as your SSH version gets more vintage, the lines get longer and longer.
Yeah.
So there's a lot of benefit to upgrading to a current version.
The only thing you don't want to use anymore, to keep in mind, please, is don't use SSH agent forwarding. That's a bad idea. If you're still using that, switch to one of the options I just showed you. These options are also in the slides. We will upload to the conference site later on. Yeah. So if you haven't remembered those, we will give you the information later on.
Yeah, sure.
So Bastion hosts.
That pretty much concludes Bastion hosts. Of course, getting to a new version is quite handy, and also the -J allows you to use jump hosts on demand and just name them by entering, which is really, really convenient when you're a mobile user like most of us are traveling with a laptop these days. That comes in really handy. Of course, there's another problem with OpenSSH and especially servers, which means host keys. And the topic of host key rotation. Of course, you should regularly freshen up your host keys.
Replace them.
Replace them. In the past, people have had this hardware failing cycle. So when your hardware broke down, you got a new server, you installed everything from scratch, and you generated new host keys by the time. Nowadays,
and you had hardware that actually generated enough randomness to properly generate keys. Yeah.
These days, VMs never die. They just start they could just reincarnate it on a new hypervisor, and you get to keep your security problems forever. So in your SSHD config, you usually have this setup, so which of the host keys are used? Show of hands, do you know? Which are used? That's a default config of an SSHD server.
Shout it out.
They're all 4 commented out, but so which one's used? The RSA one, okay. Other opinions? Who connected in the background to check? Nobody? They're all 4 offered. If you comment out all host keys, the system takes all 4 default keys, and if it doesn't find those, it generates them. Because there's usually a wrapper script that does it for you. If you get rid of that, your SSH does not come up anymore, and you just locked yourself out. So if you want to improve your security setup, that's quite easy. You remove the uncommenting of those lines, and now you only get the RSA host and the ED25519, and the old DSA and ECDSA keys are not used and offered to the client anymore. And
that's something you actually want?
You really want, and at least RSA is a good fallback, which is supported on all SSH clients, not only OpenSSH. And ED25519 is, of course, the recommended way to use these days, but you need a fairly new client.
And don't forget, if you comment that those 2 lines out, you have to restart the SSH server to make this actually work. If you do that, keep another shell open in the background just in case. Yeah. It of course never happened to me, but I've heard of people actually having problems.
We've heard of people who said, okay, where's my serial cable? I need to get to the data center. So when you want to rotate keys and use a new set of keys because your old RSA keys are really short and you want to ramp up the game to 4096 bits, which is fine, you generate new keys with SSH keygen as you usually would. And on your SSH 6.8 or above server, you just add another host key line for each type. So that's pretty easy.
And please note the naming scheme McLemmon invented here, adding the year to the key name, so it actually makes self-documenting system configuration.
That's totally innovative, adding 2017 to a key. So that at least 2022, you know, oh, that's really old. And the keys are offered in that order in which they appear in your config files. It's really, really simple to use. And once 2017 comes, you just comment out the old lines, and all the clients that have connected in between that window, the time window, will already have been offered the new keys. So they already should know about this. Of course, you need an OpenSSH 6.8 or higher on the client side. And since OpenSSH usually comes with a pretty sane and secure default, it will just ignore any other offered keys. So you need the update host keys parameter in your config file. Because that has 3 simple values, yes?
Just to make that clear, this was all done on the server. We still have to take a look at the client on what the client actually does with the information and the keys the server sends down. So this is configured and controlled through the update host keys parameter.
Yeah, that has 3 simple values. The default is no, just ignore any additional keys the server offers. Of course, you can set, well, I trust this server admin because it's me.
Then you can say yes.
Should not, or you shouldn't trust yourself. Yeah. You can just say yes, then any additional keys the server offers will be automatically added to your known hosts file. And also any keys you have removed from the server will be automatically removed from your known hosts file. So that is fully automated setup for your users. And as a sysadmin, of course, you're slightly paranoid by trade, and you can set it to ask, and any change the server offers that differs from your known host file, you will be asked to prompt with yes or no if you want to accept new keys and if you also want to remove outdated keys.
But do keep in mind, I have to reiterate that the default setting for update host keys is no. So you can do on the server whatever you want unless you reconfigure the client. It won't automatically update the keys on the client. Yeah,
so you need to talk to your users. Actually, yeah, I don't like that either.
Just push them down a sane configuration.
Yeah.
So that would be the sane configuration for a sysadmin?
Yeah. On your client, of course, you use the host star option to set your generic defaults that are applied to all the host configs. and you just say update host keys ask, and that is all you need to do, and you're fine. You get to know when new keys are offered.
For example, if you have a host that is, for example, managed by McLemmon, and you trust him for some obscure reason, you can always override that with another host entry where you put in update host keys, yes, and you won't get asked any questions and get the updated version. The other thing to say is that you need, on the server, you need the public and the private key of the new key files. You need both of those files. You can't move the private key files away. They have to be on the server. That was a configuration done earlier, but that didn't work out.
That didn't work out so well, so the server actually has to prove it also has access to the private keys and needs to sign those. So the server actually needs to have access to the private keys to prove to the client it really has access to those keys, and you can't just publish random public keys and then run into trouble.
As we still have 4 minutes left, I think we can do 2 more topics.
Is that 4 minutes,
5 minutes
before Q&A?
Yeah,
or?
yeah, it's 5 minutes.
5 minutes before Q&A, okay. That's very nice. So what do we do? Debugging?
Yeah.
Client hardening?
Yeah.
Client hardening?
Client hardening.
Client hardening. Okay. Bonus slides. Client hardening. There have been 2 CVEs on OpenSSH which apply to the client in between versions 5.4 and 7.1. It was fixed in 7.1 patch level 2. These are the CVEs. That's an information leak and a buffer overflow. It was an undocumented configuration option on the client, which was called use roaming, and you just set that to no on your client. This does not apply to the server. This is all you have to do to fix it. If you're running 7.2 P2 or up, that is already fixed in your client.
But it doesn't hurt to set that anyway.
Yeah,
so
it will not do anything.
So that would be one part of the configuration you basically want to push down to the clients.
Yeah. Of course, when doing a lot of configuration with your client and your server, you somehow end up at a situation where things don't connect anymore and you need some debugging. So there's 2 easy things that probably not that well known actually. Yeah. There's minus capital G, and this will give you the complete host configuration that is applied to that connection, which means the host star and your specific host overrides for that connection. It's like if you're using postfix, it's postfix-n. This is the equivalent for OpenSSH, is -G.
This will combine all the configurations from all the places on your machine to put together. So this is what is actually applied to that connection. That's
so you
rather
see
useful.
Where parameters are picked up. Of course, you already know the -v, the verbose mode, and you can use up to 3 Vs. And this should actually get you through most of the problems you run into connections. Of course, just in case, there's always serverfault.com where you can ask questions, or Twitter.
Which basically is the same.
And since every one of us has a legacy system in their basement, like some Solaris, AIX, HPUX, Next, so we all have one of those in our basements. And now that we have a secure and sane default crypto config, you'll run into your old Samsung refrigerator, which does not support these nice options. And there's a nice thing, you can add additional ciphers or key exchange methods to a certain host without changing your defaults, by just adding a plus and then adding some legacy cipher or legacy key exchange mode. So you don't have to override anything or set bad defaults. Just go with the good defaults and override them host by host on a on-demand base.
Which basically concludes our talk, and I think we have 1 or 2 minutes for questions. Thank you very much. Wir werden immer schneller.
So, are there any questions? Are people thinking they have SSH configured securely now, or need to know more information? Okay.
We scared everyone off.
Yes.
No, we didn't.
No.
Okay.
No, we haven't done cameras yet. No, we haven't done certificates yet.
Maybe I missed this, but for this jump host thingy, which is in a new SSH versions, do you need it on both client or server, or is it just a client version? Or
You need it on both.
Both sides.
Both sides, yes. And you need, let me pull this up again. You need port forwarding enabled on the server. If port forwarding on the server is not enabled, the -J option will not work. You have to fall back on either TTY forwarding or netcut or something else.
So, more questions? No? Then enjoy the coffee break.